Today we'll study complete kinematics. Kinematics is branch of mechanics that deals with study of objects in motion where cause of motion or the quantity causing motion is not taken into care or not considered, where cause of motion is not considered. Here is external force that causes motion of an objects. And mechanics is branch of physics that deals with objects in motion, and physics is branch of science in which study nature and natural phenomena. Nature is the physical world we see around us. Science is a systematic study using scientific method to gain knowledge or information on any subjects. Now, we can say mechanics can be subdivided into study of objects at rest, study of objects in motion. Here again, if cause of motion is not considered, without considering its cause of motion, or with considering cause of motion. Cause of motion is the external force that causes motion of the object. If object is at rest, branch of mechanics in which we study objects at rest is statics. Whereas branch of mechanics in which study objects in motion where cause is not considered is our kinematics. Where cause is considered, that branch of mechanics will be told as dynamics. Now, under kinematics, we can have motion of objects in 1D, in 2D, or in 3D. Motion of an object can be of 1D or one-dimensional motion, 2D or two-dimensional motion, or 3D or three-dimensional motion. 1D motion is motion in straight line. Motion in straight line. Two-dimensional motion is motion in plane. Three-dimensional is motion in space. In two-dimensional motion, coordinates of an object, only one coordinate of the object changes. Only one coordinate of an object changes, then we say object is in one-dimensional motion. That means in one-dimensional motion, only one coordinate of the object will change. Whereas in two-dimensional, two coordinates will change, and accordingly in three-dimensional, all three coordinates of the object will change. Now let us concentrate on one-dimensional motion. As you said, one-dimensional motion. In a one-dimensional motion, only one coordinate of the object will change. These number of coordinates are as per coordinate system we are using. Coordinate system. The coordinate system is a set of perpendicular axes and their cross section is origin. As per the number of axes selected, if one axis, if two axes, one axis, two axes, or three axes are used, as per that it will be termed as one-dimensional or 1D coordinate system, here 2D coordinate system or 3D coordinate system. That means 2D coordinate system will have two coordinates, 1D coordinate system will have one coordinate, and 3D coordinate system will have three coordinates. Let us start. What is motion? Motion of an object is the change in position. Motion of an object is change in position. What is position? Position of an object is the location of the object with respect to a particular reference, with respect to a reference point. Comparing this reference point, we identify the location of the object, and this location says the position. In physics, we will identify position of an object using coordinate system, and coordinate will give the position. The coordinate is the position of the objects. In one-dimensional motion, axis is along the direction of the motion, along the direction of the motion. It is, that means motion in straight line. Hence, this type of motion is termed as rectilinear motion. If an object changes its position, and direction of motion is termed as, suppose, x-axis. X-axis will have different coordinate at different positions. Suppose at some time t1 and at some time t2, at time t1 coordinate of object was x1 and time 2 coordinate of the object was x2. This is the position A and this is the position of the object is at B. It has taken some time t. During this change it has crossed certain distance, certain path is s, and time taken is t. Now we say during this motion it has covered some path. This path, actual path length is the distance. Is the distance covered by the object is the actual path length covered by the object. Suppose take this distance covered during time t, then this distance, rate of change of this position or distance by time is our speed. Is the speed of the object. If speed is, say, v, distance traveled s in time t, we get a formula v is equal to s by t. Now, if object is covering equal distance in equal distance, says in equal interval of time, we say object is in uniform motion or speed is uniform. Else the speed will be non-uniform. That means covering unequal distance in equal interval of time. Then we say it is, the speed is non-uniform speeds. In that case, we need to find out two speeds. One is our average speed and other is instantaneous speed. Average speed is the total distance covered by total time taken. He says if object is not uniform and is covering different distances in different interval of time, in first 1 hour some distance, second 1 hour other distance, third 1 hour some other distance, another 1 hour some other distance, about 2 km, 3 km, 4 km, 5 km, then it is said that he is in non-uniform speed. Suppose other object is moving equal distance in equal interval time. First 1 hour 2 km, second 2 km, second then 2 km, then also 2 km. In each 1 hour it is covering 2 km. Then we say our time interval is 1 hour, 1 hour, 1 hour, 1 hour, and distance 2 kilometer, 2 kilometer, 2 kilometer, 2 kilometer. In that case, it is said that it is in uniform motion or with uniform speeds. Whereas once the distances are different, it is a non-uniform motion and it has a non-uniform speed. In that case, we find out what is average speed. Average speed becomes the total distance it has covered, 2 plus 3 plus 4 plus 5, total distance by total time it has taken. In this case, it will be 2 plus 3 plus 4 plus 5 kilometer by total time is 1 plus 1 plus 1 plus 1. This is arithmetic mean is our average speed. Then instantaneous speed is at any particular time. At any particular time, what is the speed? Instant speed is speed of an object at any particular instant of time. At any particular instant of time. It is not the time duration, it is the value of the time at that particular time. What is the value of speed that we say instantaneous speeds? Now, depending upon the direction is considered or not, we can classify our motion as scalar motion or vector motion. Any motion can be classified into motion of scalar nature and vector nature. If quantity has only magnitude, then this type of motion is scalar motion. Whereas if quantity has magnitude and direction, this type of motion will be of vector nature. Is scalar nature motion and vector nature motion. Under this, we will have distance and speed. Speed we studied, average speed, instantaneous speed. Average speed is V average is total distance covered by the object by total time, whereas instantaneous speed is V instantaneous is the smallest distance covered during the smallest duration of time, delta t, where this delta t tends to 0. It says ds by dt is our instantaneous speeds. Whereas if quantity has magnitude and direction, then it will be termed as vector quantity. In this case, distance plus its direction, speed plus its direction will have some new quantity that will be our vector quantity. Distance plus this direction will be displacement. Distance wise change in position, direction was not specified, and in displacement direction is specified, hence it is the same change in position in a given direction. Displacement is change in position by an object in a given direction. Again, in same way, speed in a particular direction, or a direction is added to speed, it gives rise to velocity. Speed was distance, speed was distance by time. Here velocity is displacement by time. Speed was change in position by time. Velocity is change in position in a given direction by time. The speed is rate of change of position. Velocity is rate of change of position in a given time. Now we'll be studying these vector quantities in one-dimensional motion. These are our displacement and velocity. If position is changing, rate of change of position is our velocity, and displacement is change in position in a given direction. That's it is final position minus initial position. Velocity is displacement by time. Another term we'll have, if velocity changes, we say the motion is accelerated. Then we say acceleration is change in velocity per time, or change in velocity per time, or rate of change in velocity. If velocity changed from some value, initial velocity was u, final velocity v, and time taken t, we say acceleration gives this value v minus u by t. Now in graph form we can say, if it is a position time graph, position time graph means time past, body was at certain point. After some time we found again it is at same time, at other time t2 again at same position, not changed. Then this type of case is told as object at rest, not changed in position. Not changed is position. Suppose some x1 at certain position, which is x1 distance from some reference point, and it is lying there throughout. then we say the object is at rest. Whereas another object, when at t is equal to t0, it was at a position x1 from some reference point, and t is equal to t1, it has changed its position. At t is equal to t2, again we find change position. That means object is changing its position. That means object is in motion. X, suppose at this t is t2, it is x2. Then we say object is moving and its coordinates is changing. At t is equal to t1, it is x1, t is equal to t2, it is x2, and at a reference point at certain time t is equal to t1, it is at let x1. From here to here it has moved. We say it is in motion from a time duration t1 to t2. Suppose a distance of s, it has crossed. This is the distance, changing position. x1 minus x2 is the distance. We say it is s, and time taken is t2 minus t1. We say t. Then speed is x2 minus x1 by t2 minus t1. In this case, this is our t2 minus t1, and this is our x2 minus x1. Then this line by this line is the, if this is theta, then it's is the tan theta, or slope of the line. That means slope of the position time curve is our speed. Now let us study vector motion, our displacement, then velocity. Another is our acceleration. It displacement is s, velocity is v, acceleration is a. Now velocity is displacement by time. This is our average velocity. Whereas instantaneous velocity is velocity at any particular instant of time. It will be ds by small time interval dt small interval delta t, this delta t tends to 0, and this is a small displacement during the time interval delta t. Hence it becomes ds by dt. And this is the slope at that particular instant of time. Now, from this acceleration, we say acceleration is change in velocity, rate of change of velocity, or velocity has changed. Suppose object started moving at certain instant of time, velocity or initial velocity say was u, and it has stopped somewhere else at the final position. It is at position A, starting position is B, final position, this final position, this is our initial position, and this is our initial velocity of the object. Object started moving and object reached here at the final position, and the velocity here was final velocity. Then during this time, suppose it is taken time t and covered a distance of s, then velocity change during time is v minus u. Change in velocity is v minus u and time is t. We get an equation v minus u is equal to at, or v is equal to u plus at, which is the first equation of kinematics. Now, while calculating area of in a geometric shape, and if the shape is of rectangular one, we say area of the object, area of this shape, rectangular shape is side 1, this is your side 2, then multiplication of side 1 and side 2 is the area of that rectangle. Here, if we draw velocity of the object with respect to time, and we say when t is equal to 0, velocity, it has its some velocity, that's u, and after some time t, it has attained a velocity that is v, that is time it has taken to change from u to v is t. This is our t from here to here, this is t. And change in velocity is from here to here, this is v minus u. Now we say area under this curve, area of velocity time curve is equal to, one side is velocity and another side is time. We say velocity is nothing but displacement by time into time, that becomes our displacement. Here we have a curve of velocity and time, and in this case object has moved from a velocity u to velocity v, and the area we get is one is rectangle area A1 and then triangular area A2. Rectangle area is this one, whose side is, one side is t, another side is u. Rectangle area, rectangular surface area is A1. A1 is u and t. Then A2 is a triangle area. Is a triangle area whose sides are, one side is t, another side is b minus u. Then area of this triangle is half of v minus u into t. The total area became a1 plus a2. Now, as this is a ball velocity time curve, and area became total displacement of the object. Total area became total displacement of the object, that is our S. And here we say it is the magnitude of S. Now we can say S is area A1, area A2, area is UT, another is half of V minus U into T. From first equation of kinematics, we get V is equal to U plus AT, or V minus U is equal to AT. Now we can say is UT plus by 2 AT into T. It became UT plus half AT square is our S. This is the second equation. This is the second equation of kinematics. Then another one is, we say if object has changed its velocity from initial velocity u to final velocity v, change in velocity is v minus u. During the motion, we say average velocity is the arithmetic mean of these two velocities is v plus u by 2. Now, the distance is, or displacement in this case, is average velocity into time, because average velocity is displacement by time, implies displacement is equal to average velocity into time. Now S is average velocity into time. Average velocity is v plus u by 2 into t. Again, from first equation of kinematics, which was v is equal to u plus at, t is v minus u by a. We can write here v plus u by 2 into t is v minus u by a. It became v square minus u square became v square minus u square by 2a, or 2as is equal to v square minus u square, and v square, then it became v square is equal to u square plus 2as. This is the third equation. This is the third equation of kinematics. Now, summarizing all the equations of kinematics, we can say we got three equations of kinematics. That is, number one is v is equal to u plus at, equation 1. V square is equal to u square plus 2as, equation 2. Third is s is equal to ut plus half at square, equation 3. We have also another equation, displacement at any particular instant of time or nth time. In this case, we will be finding out nth second. Distance covered or displacement at nth second is u plus a by 2 2n minus 1. U plus a by 2 2n minus 1 will be the displacement at nth instant of time. Now, once we have kinematic equations, using these equations we can find out unknown values of the related to motion. Suppose initial velocity is given, time given, final velocity given, acceleration you can find out. If acceleration given, time given, final velocity you can find out. That means out of all these four, we have variables, or that is our velocity u, v, a, t, s. If any 4 is given or any 3 is given, we can find out the fourth one. V and u given, a given, we can find out t using this equation. V given, u given, a given, we need to find out s using this equation. U given, t given, a given, we can find out s using this equation. That means using this, out of any this equation, we can find out the unknown value, unknown parameter of this equation. Okay. Now we can consider motion will be either in horizontal direction or will be in vertical direction. Horizontal motion is the motion parallel to ground. If an object is moving on any road or parallel to ground, it is a motion of horizontal motion. Vertical motion is if object is moving perpendicular to ground. In that case, we can say it is either going off from ground or falling towards ground. That means upward motion or downward motion. This is an example of falling any object from top to ground. This is motion under gravity. Motion under gravity. Now, under motion of gravity, these kinematic equations will be applicable, whereas this is motion under gravity. We know kinetic equation V is equal to U plus AT. Here acceleration will be G. Motion under gravity, A will be our G. It may be plus G or minus G. If it is upward motion, object moving from down towards upward, this acceleration will be minus G. Whereas for downward motion, object is coming from top towards ground, acceleration will be plus g. Here v plus, as per this equation, as per value of a, kinetic equation become u plus gt v square is equal to u square plus 2a s 2g s, then s become ut plus half at square, or in this case gt square. When value of a becomes minus g, here v becomes u plus at or u minus gt. V square is equal to u square plus 2s or 2 minus g s, and s become ut plus half minus g t square. Here, if any object is thrown upward, it will attain certain height, and at maximum height its velocity will be 0. Again it will come back. Suppose velocity at initial position is u, then final velocity will be v, which will be 0, and time suppose taken t1. Then using kinematic equation we can say v is equal to u, because it's upward motion, a is minus g is equal to u plus at or u minus g t1, v is equal to 0 at maximum heights, then 0 is equal to u minus g t1, or t1 is equal to u minus u by g. This is the time it will take to reach maximum height is t1, which is u by g. G is a constant. This acceleration due to gravity, that's 9.8 meter per second square, or somewhere else it is assumed 10 meter per second square. Now depending on the value of u, maximum height time will be changed. Next is, suppose it has attained a height h, we can find out from our equation v square is equal to u square plus 2as, here u square plus 2, a is minus g, s is our h. Again v square, v is our 0, then 0 is equal to u square minus 2gh, or 2gh is our u square, or h became again u square by 2g. Now we are able to find out the height. If we have thrown an object with a velocity u, what is the maximum height it will attain? We can calculate using this second equation h. Now suppose object has reached its maximum height h, while going it is t1, and while coming it is t2. Now it has gone in upward direction. When it has moved with initial velocity u, and at the end it has reached here, the final displacement is, because at start it was on ground and at the end of its motion it was again on the ground, final displacement, net displacement is 0. In and motion we have done upward motion. Upward motion means a is our minus g. Now we can say, using equation s equal to ut plus half at square, s is our 0, is equal to u, and in this case total time it has taken from start to reach the ground is t, which is our t1 plus t2. Here it is t plus 1 by 2. As we have considered upward motion, this is our minus g and t square, or gt square by 2 is equal to ut. Then t became 2u by g, 2u by g, which is equal to 2t1. This is the time it will take to reach the ground, equation 3. Using this, we can calculate any unknown parameter using other given parameters. Suppose if the object is thrown from any tower of height h1 and initial velocity was 0, it is fallen freely and it has reached the ground after some time t1. Any object is thrown with initial velocity 0 and is fallen due to gravity's acceleration is g. This type of motion is said as freely falling body. Freely falling body. The freely falling body initial velocity is equal to 0 and t time taken is suppose t1 and height is as distance it has covered is the height of the tower h1. In that case, we can find out what is the velocity with which it will hit the ground. V will be again u plus at. U is our 0, a is our g, and t is says t1, or using distance or displacement equation, b square is equal to u square plus 2as. Here is equal to 0, 2, then g, then this is our h1. Then v became 2gh1 under root. So this is the velocity at which object will hit the ground. And now from here, if you can find out t1 or time it will take, velocity by g, or using equation s is equal to ut plus half a t1 t square. Here h is s1 is equal to 0, half a is equal to g, then t is equal to t1 square, then t1 square became 2h1 by g, or t1 became 2h1 by g underscore. You can find out this one. This is the velocity at which the object will hit the ground, and this is the time it will take to touch the ground. Another case we can have is from the tower. If object is thrown, it will again go upward. It will go to a maximum height where velocity will be 0, and it will cover same distance. Suppose h1 is the height of the tower and h2 is the height it has crossed to reach maximum height. Then it will h2, and this will be again your h1, and you will hit the ground. Suppose initial velocity is u, is the time t1, this time suppose t2, this is your time t3. Now in this case, again object will be attain its maximum height at with a velocity 0. During this upward motion, it is your minus g. We know t1 will be our t2. Total time period will be our t1 plus t2 plus t3. At position B, suppose this is a position A, this is our B, this is our C, this is our D. At A, initial velocity is U. At B, at maximum height, velocity is 0, that is our V. V is equal to 0. Now we get V square is equal to U square plus 2AS, whereas A is our minus G and S is H2, or H2 became 0. U square by 2G is the H2. Again, if we are considering the upward motion, while starting from tower top to reaching its ground, net displacement will be h1, and once I consider upward motion, but it will be at ground the opposite direction to this initial position, it will be minus h1. Hence, using equation S is equal to ut plus half at square, we get minus h1 is equal to u. Total time period taken is t plus half is our minus g, again t square here we get equal to u t minus half g t square is our h1. Or using downward motion from here to here, distance covered is